shape function or interpolation function. Now in this class we'll learn what is shape function, or we can say that interpolation function. What is an interpolation function? We'll discuss. So this in finite element method analysis, we discretize the solution region into finite elements. To conduct the analysis, we assume a displacement model to approximately indicate the variation of the displacement within this finite element. The polynomial chosen to interpolate the field variable over the elements are called as shape functions. Simply we can say that the polynomial chosen to interpolate the field variables over the element are called shape functions. So for understanding equation, we may say that u is equal to n1 u1 plus n2 u2 plus so on n n u n. This is equation 1. This is the displacement equation. So in this displacement equation, here n1, n2, n3, and n4 or nn are the shape functions of this particular element. So where u1, u2, u3, un are the nodal displacements. U is the displacement at any point within the element. So for one-dimensional case, these polynomial equations may be chosen whether it is one-dimensional, two-dimensional, and three-dimensional. So one-dimensional case, we may simply write it as u of suffix x direction a naught plus a1x. This is another equation, one-dimensional case. Similarly, u of x is equal to a naught plus a1x plus a2x square. This is third equation. For simply one-dimensional case, we may rewrite it as. Similarly, suppose this polynomial equation for two-dimensional case, we may write it as u sub x comma y. You may say that a naught plus a1x plus a2y. This is the fourth equation. Similarly, for four noded, that is three noded, x comma y is equal to a naught plus a1x plus a2y plus a3 xy. This is equation 5. So these two equations are equation 2 and 3 represents the one-dimensional polynomial equations. These two, 4 and 5, represents the two-dimensional polynomial equations. So from this polynomial equations, we may find out its shape function. This polynomial equation, you may say that this is the interpolation function which shows the relation between the nodal points of the particular element. Okay, with reference to this one, we may find out these shape functions. For finding these shape functions, we follow the different approaches. One of the simplest approach for the one-dimensional case is Lagrange's interpolation functions. What is that? Lagrange. G-R-A-N. Lagrange's function, interpolation function. So this Lagrange interpolation functions, suppose first we have a function which when plotted as behaves as shown in figure. Yes, first we assume one function is there. It is x and y axis. This is x. In this direction, y axis u displacement. So one function is variation like this. So at point 1, this is a u1 displacement at point x1. Here the displacement u2 at point x2. Like that, x suffix n, u suffix n. Like this is the function. So suppose we want to find out the u of x. Now u of x is equal to n1 u1 plus n2 u2 plus so on nn un. This is an equation 1 in this. So where n1 to nn are the shape functions. So how to find out the shape functions for one-dimensional case? How to write this? It is simple. Suppose here is n1. n1 is the shape function of this particular polynomial equation. So in this, n1 is equal to first x minus x2 into x minus x3, so on x minus x suffix n divided by x1 minus x2, because 1 is the constant, x1 minus x3 is 2, so on x1 minus xn. This is the shape function 1. Similarly, n2, shape function 2, x minus x1, x minus x3, because 2 is not written because it is a second node, so on x minus x and divided by x2 minus x1, x2 minus x3, so on x2 minus xn is the shape function 2. Similarly, n suffix n also we may write it as shape function n, x minus x1, x minus x2, so on x minus xn minus 1. Similarly, xn minus 1, xn x1 minus x2, so on xn minus xn minus 1. This is the shape function. So here n1, n2, nn are the polynomial of degree n, the shape functions. In these shape functions, we may say that some of the points, important but node points of the shape functions. Note in the shape functions, the unit value at node 1 is 1. Suppose unit value n1 is equal to 1 at node 1. So remaining all the points, this is 0. Remaining all the other nodal points are 0. And 1 is equal to means n2 is equal to 0. Like that n is equal to 0. Similarly, n2 is equal to 1 means remaining all n1 is equal to 0. Like that n is equal to 0. These are the node points, how to remember.